Now, we have two ways of balancing the redox reaction. You have the ion-electron method, in other words, half equation method. Then we have a change in oxidation state method. Now, the most common one that we use is the ion-electron method or the half reaction method. Later, I will look at the change in oxidation state. I will give an example. Now, let's look at this example. We have ion 2, selenium ion 4 to produce ion 3 plus this. In balancing redox reaction, we will go through some steps. Now, the first step is to separate the equation into half equation or half reaction. We are dealing with the balancing of half equation or reaction, and we do the oxidation balancing later. So you have to separate the two into oxidation half and then reduction half. Ion is moving from +2 to +3, so that is oxidation. Selenium is moving from +4 state to +3, then we say reduction. Now we do balancing each half equation. Let's have the first one, the oxidation half, 2 plus, to give you 3 plus. Here you realize that there are no oxygen to balance, there are no hydrogen to balance. So what we have to balance are the charges. This part, as I said, is oxidation part. How do you balance the charges? A total of 2 charges here, total of 3 charges here. In oxidation reaction, it is always loss of electron. So in oxidation reaction, we expect that the electrons come to the product side. That will help you balance the equation very well. Not necessarily always that. Not always that, but that will help you. Now, by adding 1 electron to this, we'll reduce the 3 to 2. Therefore, the equation will be balanced. So we have balanced the charges. We are done with this. So the total charge here will be 2. Total charge here will be 2. Then we are done with the charges. Now let's come to the other one, the selenium, +4 to 3. In reduction reaction, always the balancing electrons are brought to the reactant side. So here, total of 4 charges here, total of 3 here. So what I have to do is to reduce this one by 1. So we add 1 electron. Then it is balanced. So total charge will be 3 here, total will be 3 here. Then we put them together. This one becomes the overall reaction. So this is the oxidation half, and this is the reduction half. Overall, we write the reactants together plus. So the electrons will cancel each other. And at the end, we have this +4 to give you F3 plus C3. So we maintain the same equation. Next question. Next question. With the next question, let's look at how we balance this. The next question. Having been given this reaction, we have Fe2 plus MnO4 to give Fe3 plus N2 plus. So the first place, you need to have oxidation half, reaction first, and reduction half. So we divide the reaction to 2. Oxidation half, this is moving from +2 to 3. That is oxidation. And this one is moving from +7 to +2, reduction. Let's balance one of them first. MnO4 to give you Mn2 plus. This is reduction part. Now, we first balance all atoms. If there are, apart from oxygen and hydrogen, we balance all atoms. Fortunately, the manganese and the manganese, they are all balanced. The two are balanced, or it's balanced itself. So we are done with that one. The next one is to balance oxygen and hydrogen. In redox reaction, when you are balancing oxygen, we use water. And when balancing hydrogen, we use H+, the ion. In this case, we say we are balancing this in acidic medium or acid medium. Acid medium. So under this one too, we have the balancing in acid medium and balancing in the basic medium. So with this one, we are doing it in a acidic or acid medium. Now, we balance oxygen with water and we balance hydrogen with H+. So you realize that we have 4 atoms of oxygen here, but we have none here. In this regard, I am going to add water molecules. So I will add 4 water molecules. It means that I have balanced the oxygen atoms. Now, when we come here, we say oxygen for water for oxygen, and H for H+. This thing must be there. Now, when we balance the water, then I have introduced hydrogen. We have already said in balancing hydrogen, we balance it with H+. So how many hydrogens do I have here? I have 8 species or 8 atoms of hydrogen here, or molecules of 8 atoms of hydrogen here. So with the 8 atoms, they have to balance it with 8 H+. We have not done with this. Now, after balancing oxygen and hydrogen, then we balance charges. We make sure the total electron at the reactant side equal the total the total charges at the reactant side should be equal to total charges at the product side. So let's look at the total charge here. A total of 8 positive and 1 negative, making 7 positives here. When we come here, a total of 2 positive here. Now this is a reduction reaction. I've told you that to be on the safer side, for a reduction reaction, bring the electron to the reactant side. So how many electrons do we need to add so that to reduce the 7 to 2? Then we have to add 5 electrons. By adding 5 electrons, let's see what has happened. So here a total of 8 positives minus 1 making 7 and minus 5 making 2. So total of 2 charges here, total of 2. Then we have balanced the half reaction half. Now if that is balanced, then we move to the other half reaction, which is the oxidation half, which is this ion 2 to give you ion 3. Oxidation half. Here there is no oxygen, there's no hydrogen, there is nothing apart from balancing the charges. So what do we have to do? I've told you that for the oxidation side, the electron must be at the product side. So a total of 2 pluses and 3 pluses, do you have 2 and 3? So how many do we need so that we can reduce? Because charges are here, we are going to balance, as I said. There's nothing to balance again apart from the charges. So we have a total charge of 2 here, total of 3. So what I have to do is that we need to introduce an electron, which will reduce the 3 to 2. Let me remind you that this is an oxidation reaction, half reaction, and therefore the electron must be sent to the product side. So I will introduce 1 electron here. So the 1 electron will reduce this one to 2. Then I have also finished with this. The total, you have this. Now, in redox reaction, we don't allow electrons in the final reaction. So we have to do away the electrons. So what we have to do is that, how do we cancel the electrons? How do we cancel the electrons? We can cancel the electrons because there are 5 electrons here. All I have to do is to multiply all these by 5. When they multiply by 5, then we can equal the electrons and can be cancelled out. So here we're going to have 5 Fe2 to give you Fe3, sorry, 5 Fe3 plus 5 electrons. But here, I don't even have to maintain it. So we write everything here. 8 A plus to give you manganese 4 oxide plus 5 electrons to give you manganese ion plus 4 water molecules. So total, doing without the electrons here, is this is at the product side, this at the reactant side, so they cancel each other. So at the end, we're going to have 5 Fe2, we are now with this, plus 8 A plus MnO4 to give you this, or remember this one first, 5 Fe3 plus Mn2 plus 4 water. This is a balanced chemical equation. So check the charges. Now let's continue with the next question. Now we have chromate ion plus hydrogen sulfide plus H plus chromium ion plus chromium 3 plus sulfur and then oxygen water. Now I've told you that before you start, we always need to separate the reaction into two: the oxidation half and the reduction half. Now the oxidation number of this chromium, that's the central atom, is will be 6. Is 6 from 6 plus to 3 plus. That of the sulfur will be -2, 2, 0. So in effect, this is reduction and this is oxidation. From -2 to 3 to 0 has been increased. That's from -2 to that. So let's balance each. So first, let's balance any of them. The reduction half to give you 3 plus. Now this is reduction half equation. Now the reduction half equation, just balance all atoms, exception of oxygen and hydrogen. So you put 2 here, the chromium here, there are 2. We have one ion of chromium here, so you put 2 here, so that you have balanced all atoms first. Then next one, in acidic medium, let's balance oxygen and hydrogen. So with oxygen and hydrogen, how do we balance the oxygen and hydrogen? We have 7 atoms of oxygen here. We have none here. It means that we need to balance oxygen. We need to put water there. So we put 7 molecules of water here, so that we can balance the oxygen. So it means here there are 7 here, there's 7 there. So that's balanced. Now let's look at the next one, which is the hydrogen. Because when we added water, we introduced hydrogen. So we have added 14 atoms of molecule, 14 atoms of hydrogen into the whole reaction. Therefore, we add 14 plus. Because we are balancing hydrogen with H plus, so 14 H plus. Having finished with the balancing of oxygen and hydrogen, then we balance charges. We balance charges. Now, this is reduction reaction. Reduction half reaction. So we should expect the electron to be here at the right-hand side. So a total of 14 charges, 14 plus, and 2 here, making 12 plus. A total of this time, this making 6. So what do we do again? We need to reduce this one by 6 or add 6 to this. Remember, electrons are negative, so we cannot add an increase to 12. We can only add the magnet to 12 to reduce it. So we add 6 electrons. Are you okay? Now, after adding 6 electrons, then we have finished with the oxidation reduction half equation. See that we have balanced everything here. Then let's move to the next one, which is the oxidation half, which has this sulfur. With oxidation half, we are to balance all atoms apart from oxygen and hydrogen. So this is the only exception, so we cannot balance this, and it's already balanced. So let's leave the hydrogen alone. From there, we move to balancing of oxygen and hydrogen. Now with this, there are 2 atoms of hydrogen here. So we have to balance the hydrogen to 2H plus. When that was balanced, we have introduced what we call 2 electrons, 2 charges here. So the charges here, 0 here, 2 plus here. What do? This is oxidation, so we expect the electron to go to the product side. So we are going to add 2 electrons in order to kill or to reduce this to 0. So that we will reduce to 0, so that we balance the charges 0, 0. Then we are done. Now let's come to this. In the overall reaction, we have to do away with the charges. So we have electrons. Do away with the electrons. 2 here. We have 6 here. So what do we have to do? Then we have to multiply the oxidation half equation, all of them, by 2. So when they are multiplied by multiplied by 3. So by 3, you realize that we will get 6 of the electrons, which will cancel the 6 here. So the reason why we multiply by 3 is that we want to do away with the electrons. So if this one is 2, then multiply by 3, so that we get a 3 electrons here. Just like we do a simultaneous equation. So here, we're going to have 3H2S to give you 3S plus 6H plus 6 electrons. But we maintain this. So 14H plus Cr2O72 minus plus 6 electrons to give you 2 chromium 3 plus 7 water molecules. Now let's look at this again. We have 14H plus and we have 6H plus. What I have to do is that we deduct from this, because this one is a product reactant, so we have to subtract. If they were to be on the same side, then we would have added, or we'll add the 2. So here we subtract this one will be off. Then this one will remain 7 water plus. Is that 7? No, 8. 8 rather. 8. Electrons will go off. What else? Water molecule. We maintain that. So in effect, we're going to have a new overall reaction. Overall reaction will be 3H2S plus 8H plus Cr2O7 minus 2 to give you 2Cr3 plus 3S plus 7 water molecule. We are done with that. So if you check the charges, you realize that they will be the same. 8 pluses minus 2 will be 6. So that's 6 here. And here 2 times 3 will be 6. 6 plus. Then if the charges are equal, then you are done for the balance. Now that is the acidic medium. Now let's look at a question under basic medium. We have 2 questions. There are 3 electrons here. There are 2 electrons here. There's a need to cancel. So what I have to do is to multiply all these by 3 and all these by 2, so that we can make the electrons to be equal. So at the end we're going to have 3Bn3 plus 18OH minus to give you 3 BiO3 minus plus 9 water molecules plus 6 electrons. Again, this one will also be 4 water molecules plus 2 MnO4 minus plus 6 electrons to give you 2 MnO2 plus 8 OH minus. So finally, what you have to do is that the electrons will cancel out. And then again, water molecules, there are 4 here. 4 off. When the 4 goes off, this one will remain 5 water molecules. Then the hydroxyl ions, here, this one will be off, this one will be off, making 10 OH minus. Now when you put them together, you form the compound. Thank you very much for your attention. Hope to continue next time. Bye bye.